Good evening, good evening, good evening to all my dear friends. Today I am here to finish the last lecture of circular motion. So today this is the fourth lecture. We are in the fourth lecture and this is going to be our last lecture. So we are going to summarize many things and also we are going to learn a basic concept which should be taught in our first class or in the second class, but I planned it to teach in the fourth class because to utilize our lectures in a better way, I thought to teach in this class. So in the last class, as if you have seen the last class, I have done the derivation of the banking of fraud and I have told what is the formula, what are the important cases which we need to know for JEE advanced questions, JEE mains questions. Okay, so I don't think that because I did the derivation very fast, so today I'm going to repeat that derivation so that we can understand it carefully and we can relate it. Okay, because it is not important, the derivation is not important, but we shall still know it for our sake of learning. Okay, so now let us start our today's class with the derivation. So we will derive derivation. Okay, so first we'll start by deriving. So what will derive? We'll derive what will be the maximum velocity for a car if a car is moving in an angle, an inclined, if a car moves in an inclined way, so in that case what should be the maximum velocity? Okay, what should be the maximum velocity limit? That if the car extends that limit, the car will fall or car will skid. Basically, we can say that the car will skid. So, if we try to visualize this case, what this case says that this is the road. Okay, it is inclined in this way, and a car is moving like this. Like this, the car is moving. Our car is moving like this. So can you see there is an inclined, there is an angle with the horizontal. With the horizontal angle is there. So this case which we want to visualize. Now if you see, there must be a certain velocity in which the car must be moving, but also there is one velocity limit. Okay, that after this extent, after that extent of velocity, we must not move. If we move, then what will happen? Then straight away we will skid or will get out of the circular track. So we must maintain that velocity, and there is also one more velocity, that is the minimum velocity. Okay, because see, if very slow this car is moving, but if it stops, what is happening? The car is going to fall down. Okay, so both will result the car to get out of the track. So we must maintain, we must be, our car's velocity must be more than the minimum velocity and it must be less than the maximum velocity. So the velocity should be in between of these two things. Now we are going to understand this, what is happening. So this is an inclined plane. A car is here. Okay, car of mass m, better to say. Now if this is the mass m, so in 2D we'll represent its movement like this. Okay, in 2D we'll represent its movement in this way. So in this case it is moving in a circular track. This is the center of the circular track. Okay, so what all are the forces which are acting on this block? First force is our mg, which is acting downwards. Okay, which always acts downwards. If we say the inclination angle is theta, normal is going to act perpendicularly upward in this direction. It is going to act perpendicularly upward. Now this angle is theta, this is 90 degree, so this angle must be equal to 90 degree minus theta as per our triangle rule. Okay, so now try to understand again. In this case, we are going to derive for the maximum velocity. So the car wants to move with maximum velocity. So see, it is moving with maximum velocity. So what should be the tendency for the car? The tendency of the car is to slip away, but it is not doing so. If it would slip away, then we would apply kinetic friction on this car or on this block of mass, but it is not doing so. So it is at its maximum extent. So what friction will apply? Will apply the static friction in this direction. I hope now you understood why it is applied in this direction. Okay, so this is our static friction. Now we'll break it into two components, as we have learned how to write the circular motion equation. So to write it, we need to break in two components. That is, one should be perpendicular to the center and the another component should be towards the center. Okay, we should try like this only. So as this angle is 90 degree minus theta, our component here will be f static sine theta. I hope you understand why it is sine theta. And here there will be two components. First component is our f cos theta, plus there will be another component. Now you see, if this is 90 degree minus theta, then as this angle is 90 degree, then again the angle between this and the static friction must be again theta. So this angle will be again 90 degree minus theta. So component will come n sine theta. N sine theta is going to come, and above there is going to be a component which is n cos theta. Okay, I hope now it is clear. So now what we'll do, we can write that n sine theta plus f cos theta is the force which is acting towards the center. So if it is acting towards the center, then this is the reason of our centripetal force, and these forces are giving the centripetal acceleration. So these forces is going to be mass into acceleration. Now what acceleration? Centripetal acceleration, because it is acting towards the center. Can you see? This is acting towards the center. This force is acting towards the center. See, if this is the center, then it is going towards the center. So our acceleration will be mv square by r. Let us say that this is our equation 1. Now what should be our second equation? That is n cos theta is equal to f sine theta plus mg. Okay, can you see that this is n cos theta which is acting above, and mg and f sine theta is acting downwards. So this should be n cos theta is equal to f sine theta plus mg. So can we write this as n cos theta minus f sine theta is equal to mg? Let this be our second equation. This is the first equation and this is our second equation. Okay, so now we are going to divide both the equation. So by dividing both the equation, what we get is n sin theta plus f cos theta divided by n cos theta plus minus f sin theta. Okay, is equal to mv square by r into divided by mg. So m and m gets cancelled, so I'm removing it. Finally, what is left in the right hand side is v square by rg. Now let us now simplify this. So if I divide both sides, means numerator and denominator, with cos theta, so I will get n sin theta by cos theta, that is n tan theta, plus f cos theta divided by f cos theta, cos theta will get as f, because cos theta gets cancelled. So also we can write f. Here f is the maximum value of static friction, so here we'll write f as mu into normal, where mu is the coefficient of friction and normal is acting in this direction. So mu into normal divided by n cos theta. Okay, so here n cos theta will be again divided by cos theta, so we'll get n minus mu n tan theta. I hope you understand why this is tan theta. Okay, now here mu, which is the coefficient of friction, can also be written as tan alpha. So here alpha is our angle of repose. Okay, that is the angle of friction. So now let us, can you see that this n, this n, this n and this n is coming out common? So we'll just write tan theta plus putting the value of mu, that is tan phi, divided by 1 minus tan theta into tan phi, which is equal to v square by rg. Okay, I'm erasing it. So I hope you have studied in trigonometric function that tan A plus tan B divided by 1 minus tan A into tan B is the formula for tan A plus B. Okay, which is equal to v square by rg. Now shifting this rg to our left hand side, we get, which is equal to v square. So simply we can say that our v will be equal to root over of rg tan theta plus phi. Okay, so this is going to be our derivation for the maximum velocity. Now again I am telling you, I am focusing on the word maximum. Why? Here the velocity which is coming is maximum, because we have taken the maximum value of static friction. Okay, we have taken the maximum value of static friction, that is mu into normal. We know that the value of static friction can vary and its maximum value is equal to mu into normal. So whenever there is to static friction used to come, what we said that static friction is lesser than equal to, what we said that it should be greater than 0 but it should be lesser than equal to, we say it like this, okay, lesser than equal to. So as we are taking the maximum value, so it must be equal to mu into normal. So that is what the case, and therefore we are getting the maximum velocity, that is this. Okay, now we are going to derive for the minimum velocity. So to find the minimum velocity, now what we'll do? Okay. So again, this is our inclined plane. Here the mass or the car is kept in this place. So what are the forces which are going to act? First, in the downward direction, mg is going to act. So mg force is acting downwards. Secondly, in this direction, normal is going to act. Why normal is going to act in this direction? Okay, many may have doubt if they have not read the Newton's law of chapter properly. So they may have doubt that a normal should act in this way. Okay, but it is not. As from the name itself we can derive, normal means perpendicular, and it acts away from the body. So can you see that this normal and the surface is making an angle of 90 degree. So therefore normal is going to act this side. Yes, some people may get confused by this. Here in this case, what used to happen, that mg used to act downward and normal used to act upward. So here many may be confused. So I am just clearing the previous confusion or basics. Okay, so we used to simply say that normal is equal to mg, but in this case it will be not so. Okay, let the inclination or the angle of the inclined plane be theta, and the particle is moving in this circular track. So as we want to derive for the minimum velocity, what we need to see, what we need to observe, that this is our particle. It is moving with such a less velocity, very less velocity is moving with. But if the velocity decreases, okay, what is going to come, that we don't know. But if the velocity decreases in such a level that the static friction becomes kinetic and starts acting upon it like this. See, it is becoming so less, and after that what happened? Kinetic friction acted upon and it fall down. Okay, the particle fall down. So here there is a tendency that static friction is acting in this direction. Okay, static friction. We need to find the minimum velocity. So here also static friction will act. Okay, we are not told to make it fall or to find the kinetic friction. We are not told that what will be the time when it will fall. Okay, we are not told like this. We are told that what should be the minimum velocity, so that the car should complete its circular motion, or car should move in the circular track. Okay, so again this angle will be 90 degree. This is going to be 90 degree minus theta. So let us make the components. So what we can say, that this is our center of the circular path. Okay, this is the center of our circular path. This angle is going to be theta. This angle is going to be theta. Okay, yes, this angle is going to be theta. So what are we going to get? That in this case we'll get fs cos theta plus n sin theta in this direction, and we are going to get n cos theta, and in this we are going to get fs sin theta opposite to each other. Okay, I hope you are agreeing with what I am saying. So it is going to act opposite direction, in the opposite direction. Okay, it is going to act in the opposite direction. So everything is perfectly fine. As everything is perfectly fine, so let us now write it. Okay, we have made the FBD, that is the second step for writing the equation of circular motion. Now let us write what are the equations. So fs cos theta plus n sin theta is equal to mg. Okay, is equal to mg. Now what is the this is the first equation, and now what is the second equation becomes? What the second equation becomes is, now there is a problem here. This is the block n cos theta fs sin theta. Now again, the acceleration is acting in this direction. The centripetal acceleration is acting towards the center. Okay, so we are not to get confused that whether we should write fs sin theta minus n cos theta or n cos theta minus fs sin theta. It is understood in this case that we'll write the second equation, n cos theta minus fs sin theta, which will give the centripetal force, so mv square by r. This is going to be our second equation. Okay, second equation. Now let us divide both these equations. So n cos theta minus fs sin theta divided by f cos theta plus n sin theta is equal to v square by rg. Now again, in the similar manner, we'll again divide the denominator as well as the numerator with cos theta. So we get n minus mu n tan theta divided by mu n plus norm n tan theta, which is equal to v square by rg. Now here mu is the angle of repose. Mu is equal to tan phi, where phi is the angle of repose. So here we'll just substitute the value of phi. Mu n minus tan phi to tan theta into n, tan phi n Okay, I hope you have understood this part. Now what we can do, that we can cancel the value of normal, as we can cancel the normal as it is coming common from all the parts. Okay, it is coming common from all the parts. So now what we can see and what we can derive, that the velocity minimum in the similar way, what it is going to come is that it is going to come our rg into tan theta minus phi under root. Okay, so the derivation, this derivation is a long process, but if we try to see, okay, we can also do it by another method, that in our first derivation what we had, this mass was having the friction in this direction. So if we put the value of friction negative in that equation only, then we'll only derive this equation. Okay, so we can derive it in this way only, but we need to remember it. Better is that we should remember it. I hope this derivation is clear. So now we are going to start the today's topic. So what is going to be today's topic? Imagine that a random path is taken. This is an observer observing that an object from this going to this. Okay, so how it is observing? First of all, it should be observed like this. Let us say this as the initial r vector and this the final vector, final r vector, final position vector. What else what will you say? You can say. Okay, so when we are observing this object, this object is going from here to here. Okay, like this it is going. So if we are observing, our head was initially in this direction, but it should be moving in this way. Okay, in this way it is rotating. It is in this way, our head is moving in this direction. Suppose this is the object and it is moving in this way. And I am trying to observe this object, or I am trying to follow this. So my head is moving. Can you see? This is the initial position vector. My head is fixed here. My head was initially at this point, but now it is moving. And the final vector, or the final position vector, is this. So my head has displaced a certain angle. My head has displaced angle which we can call as theta. Okay, so our head has displaced a certain angle that we can call as theta. So here what we can write, that this theta is our angular displacement. This theta is the angular displacement. Now suppose again this is the object kept here and it is moving like this. And with the object, my head is also moving. See, my head is also moving. Now there are two cases. In the first case, the object is moving like this. Okay, object is moving like this, and my head is also moving like this. Or suppose if I want to move from this place to this place, or my head wants to move from this place to this place, so I can move in a slower manner, or I can also move in a faster manner. So now problem which arises, that in the both case we are moving the same angular displacement. Okay, so to differentiate, to find the difference between it, what we do, that we also calculate the angular velocity, which is represented by omega. This is our angular velocity. So now this angular velocity should be the rate of change of angular displacement according to our definition. By definition we can say, suppose my head is moving in this, so the time, if the time taken is t, if the time taken is the t, so what should be the omega? Let us talk about average omega. So average omega should be our angular displacement divided by time. This should be our average. But if we want to find the instantaneous, then we will differentiate it. So d theta by dt is going to give our angular velocity. Now again, in the similar manner, changing the angular velocity, okay, changing the angular velocity with respect to time will give us angular acceleration. So this is represented by alpha, which should be equal to d omega by dt. I hope this portion is clear to everyone. Okay. Now, suppose, let us imagine a case where suppose this is a person. Here there is one object and it is moving following a path like this, and it finally reaches this. Okay, it finally reaches there. This is the path of the object. This is the initial position. This is the final position. This person, the person is observing is, the person is observing this and it is rotating its head and observing the another particle. So it is moving its head. Okay. So the initial radius vector, I often say radius vector and position vector, so you can understand that it is the position vector. Okay, this is the initial vector and this is our final radius vector. This is our final radius vector. So now if we want to find out the omega, if we now want to find out the omega, what we'll do, that if this is theta, then with respect to this person, that is A, let's consider. So with respect to A, omega of A should be the displacement divided by time. This I am talking about the average omega. But if we want to find the actual omega, then what we can do, we can just differentiate it and we'll find it, the omega. Okay, now omega changes with frame of reference. How we can say that? Suppose there is a person B here and the person is observing. What he is observing, that a particle is here and it is going here. So his head is still, because what he's observing, he's observing like this. The particle is going from here to some final position. So person's head is not moving. In this case, specifically if I talk, what I can say, that with respect to omega, with respect to person B, in this case the angular displacement theta is equal to 0. So if theta is equal to 0, then our angular velocity is also equal to 0. Okay, and we can also say that angular acceleration is also equal to 0 because our theta is equal to 0. We can say like this. Okay, I think it is clear. So the theta changes, or the angular displacement, angular velocity, and even angular acceleration changes with different frame of reference. Now we are going to enter in the dynamics part of this thing. Suppose this is some initial position, an object is here, and it finally reaches to this position. So what happens if the object moves with a velocity of v? Okay, if the object moves with a velocity of v. So let us try to understand that if this angle is theta, so, and if we connect and draw line in this direction, this angle again becomes our theta because these both angles are same. So if we now try to see that velocity is a vector quantity and velocity vector acting on this direction, so this velocity can be broken into two components. The first component is v cos theta and the second component is v sin theta. Okay, there may now a question arise that initially the object was in this direction and it was supposed making a length L, but now in this case the length increases, so something or the other thing is extending the length of this initial radius vector. So now we have to observe and imagine that this is the object. So when we broke the component of velocity, what we saw is that the above component is v cos theta. So the v cos theta component is trying to move this upward. It is trying to increase the length of the radius vector, initial radius vector. So it is trying to increase the length of our initial radius vector. And what this v sin theta is trying to do is it is trying to rotate this. So our resultant goes in this direction, and because of these two vectors, components of vector, the object moves in this way and our length increases. So if we want to write in a mathematical way, what shall we write? Now again, think of the previous lectures where we learned, or the previous concept which I have taught right now, that what is the angular velocity? Angular velocity is the rate of change of angular displacement with respect to time, or we can say the rate of change of angular velocity. Simply we can say that. So here can you observe that this is changing the magnitude of length. This is the changing magnitude of the radius vector. So if we differentiate the magnitude of our initial radius vector, then what we shall get? We will get the v cos theta. Simply we'll get v cos theta. Okay, I hope this is clear. Like we read that in a circular motion, what happens? That this is the tangential acceleration. So the tangential acceleration is responsible for changing the magnitude of velocity, and the centripetal acceleration is responsible to give the direction, or it was responsible to provide the direction. So in that similar way, we can understand here also that this v cos theta is responsible for changing the magnitude of our initial radius vector, and this v sin theta is changing the direction. So the v sin theta is changing the direction. So this we can write from this we can write. Okay, now try to understand that the object is here and a person observing, the observer is present in the origin. The object is trying to move in this way, okay, in this way, or in better language, if we use better language, we will say that this component of velocity is changing the direction. So let us write v cos theta changing length and v sin theta changing direction. Okay, so as v sin theta is changing the direction and it is rotating in this way, so this is the reason, or the v sin theta is the reason for change in omega. Okay, it was like this. Now our head is rotating in this manner. While observing the object, our head is rotating in this manner. So who is providing the omega? The omega is being provided by the v sin theta. So this is going to be our velocity, and this is our initial radius vector. Let's consider the length between the observer and the particle is initially r. So omega is velocity by r, we can say, right? Omega is velocity by r, as we read that v is equal to r omega. So we can also say that omega is our velocity divided by r. So here we are going to take this velocity, because this velocity is only changing the omega. So v sin theta divided by small r, as this is the distance. Okay, I hope this is clear to everyone. Now we are going to do a small problem. Based on this. Suppose this length is 2 meter. The angle is this is our initial radius vector, this is our final radius vector. The angle made is 30 degree. Okay, the angle made is 30 degree. The object was initially here and object went in this way here. The object finally went here. So velocity is acting in this direction. if we are seeing that this angle is 30 degree, so again this angle is also going to be 30 degree. Okay, this angle is also going to be 30 degree. So we will break into further two components of velocity, that is v cos theta or v cos 30 and v sin 30. Okay, so if we are told to find the omega, what we'll do is we'll write v sin 30 divided by the r. So here r is our 2, so v sin 30, which gives us half divided by 2. So omega is v by 4. Okay, omega is v by 4. Omega is our v by 4. Again, the question may ask, or it may ask that what is the change in length? What is the rate of change of the length? They may ask, okay, they may give that what should be the, or they may write it like this. What should be the change in this? So this is equal to v cos 30. So we can write it v root 3 by 2. This should be our answer. Okay, small application based question on this. These questions may be asked in our JEE mains examination. Though they are very easy to solve, they are very easy to understand, but still it may be asked. So we need to take care of these things. Now let us again come back to our article. This is our initial radius vector, this is our final initial radius vector. This is the angle theta. Object is kept here. It moves. Here. Okay. So if this angle is theta, a velocity is there. This angle is also theta. So this component is v sin theta and this component is v cos theta. Okay, is it clear? So what we observe, let me write it fast. The magnitude of the radius vector changes with v cos theta. And the omega is equal to v sin theta by r. So these are all things we saw. Now if we now try to understand or try to take a special case where we say that this velocity, this v cos theta value is equal to 0. Okay, this v cos theta value is equal to 0. So now what we'll see, that only one component, that the v sin theta is going to act. So when the v cos theta value is equal to 0, we knew that the v cos theta value changing the length, or we can say the magnitude of the radius vector. So the v cos theta was changing the length, this length, see, can you see, this was small and this, the length, finally length become big. So it was changing the length. So when the value of v cos theta is equal to 0, when the value is equal to 0, then what we can say that there will be no change in the length. So if our length becomes constant and this radius moves with omega in this way, or it rotates like this, so can you visualize that this is going to complete the circular motion, it should complete the circular motion. So we can say that this object is now going to do a circular motion like this, which we have observed previously. So from this v cos theta expression, what we can say that cos theta is equal to 0, so theta value should be equal to 90 degree, right? Our theta value should be equal to 90 degree. Now can you see that a 90 degree is made between the our velocity and the initial vector. So we can see that theta is 90 degree. Okay, this proves that whenever a circular motion is occurring, this is the radius of the circle, the velocity which is acting in the tangential direction is always making 90 degree. Okay, we have learned in our first lecture that the velocity is acting in a tangent. We have also learned in another way that suppose velocity acting this direction, there is a force here. If the angle is like this, so there is one component that will go here, that is f sine theta, and one component f cos theta. So this f cos theta is giving the tangential acceleration and this f sine theta is giving the centripetal acceleration. So we have learned in various other ways, but this thing proves that the velocity is always perpendicular to the radius, or velocity is the tangent. Okay, so the force which acts along this velocity is also a tangent. That's why we used to say that it was our tangential acceleration. The acceleration was the tangential acceleration. Okay, we used to say like this, right? Could you recall? Could you remember? Now I hope you are understanding why I am taking this class which is the very basic class at the last. Okay, so now if we put value of theta is equal to 90 degree, then what we will get? So omega is equal to v sine 90 degree divided by r, or omega is equal to v by r. Since sine 90 degree is equal to 1, so omega is equal to v by r, therefore v is equal to r omega. Can you see? It has been proved again that v is equal to r omega. And if we differentiate this v is equal to r omega, if we differentiate both sides, what we'll get? We know this is our magnitude of velocity, that is speed, and differentiation of speed gives us tangential acceleration. So r is a constant and differentiation of omega will give us angular acceleration, that is alpha. So we can also derive that tangential acceleration is equal to r alpha. So can you see how we are relating the concepts with each other? So if we have related like this, so can we say that whenever there is a random motion and an object is moving with a velocity, so circular motion is the special case of that? Can we say the circular motion is a special case of that thing, right? Can we say like this? Can we say? Yes, of course we can say it like this. Okay, so I hope it is clear, and I hope you have understood, and you have also felt it. Okay, you have visualized, you have understood how it is happening, because I have written steps, I have helped you to visualize, so you can now relate that what is circular motion, how it is happening, why it is happening. Everything is clear to you, and you are also able to solve the JEE mains and advanced questions. So this is what I want. This is what I want. Okay, now let us talk about the direction of omega. The direction of omega, or the direction of our circular motion. Okay, so wherever our direction of circular motion be, there only we'll get the omega of our circular motion. Okay, at that direction only our omega will be. So direction of circular motion, we can find it using a rule, that is right hand thumb rule. So using this right hand thumb rule, we can easily find the direction of any circular motion. Suppose this is a circular motion. Okay, this is our circular motion, and it is occurring in this direction. It is happening in this direction, and we are told to find the omega of it. We are told to find the omega of it. So in this case, let me specify this case, that it is kept on a horizontal floor and it is being rotated. You can say this case. Okay, it is kept and it is rotated. So what we need to do, we need to rotate this. This is rotating in this way, it is rotating in this way. So what we need to do, we need to rotate our hands in this direction. Okay, in the same direction of the circular motion. So what we observe, that the direction of omega is perpendicularly outside. Perpendicularly outside. So this perpendicularly outside we write as plus k cap. Okay, so the direction of omega is plus k cap. Direction of omega is plus k cap. Or we can also remember it that whenever the circular motion is in the anti-clockwise direction, then omega's direction in the k cap, positive k cap direction. Similar goes for our clockwise direction. So what happens in this case? See, we are moving our hand. We are moving our hand. So what we get, that our direction is inside. Inside. So in this case, this is clockwise direction and the direction omega is inside. Okay, minus k cap we can say in better language. So this k cap positive k cap, negative k cap. I will talk about them in detail in the rotation motion. For now, you can remember that if it is perpendicularly outside, then we use the word plus k cap, and if it is perpendicularly inside, then we talk about minus k cap. Okay, so let me write, this is perpendicularly inside, polarly outside. Okay, so now let me erase it. Okay, let me ask you a simple question, that have you observed that whenever, if you have seen a train, or let me say that if you have seen a car moving with a velocity v, whenever we see that the distance is, whenever we are closer to the car, if it is going, let this be the initial position and this is the final. So whenever we are rotating our head and trying to observe the car, suppose this is the car and it is moving like this, now I am trying to rotate my head. So if when we are closer to the car, what happens, that our head moves faster, but if the distance between the car and the observer is more, then see, the angular displacement is less. And this is moving the head, this observer is moving its head. Okay, and this is case 1, and case 2 is that, suppose the distance is 5r. So we see the omega and the angular displacement remains same, but the omega is less. So why this happens, why this contradiction takes place? We have often seen that when we observe a train from a greater distance, we see that how slow it is going. Okay, how slow, in a slower way it is going. But when we watch the train from the platform, which is very close to the train, then we see the train passes with such a high speed. So why this happens? Why this happens? We know that omega, you know that velocity is equal to r into omega. So what we can write from this, that omega is equal to v by r. Okay, if the velocity is constant, the speed of the train is constant. The speed of the train is constant. In this case also it is moving with v. In this case also it is moving with v. So we can say that omega makes an inverse relationship with r. This means omega is inversely proportional to r. If I want to make this more simpler, I can say that if omega increases, then the r should decrease, or if the r increases, then omega should decrease. So if omega increases, then r should decrease, and if r increases, then omega decrease. So this is what we call as inverse relationship. Okay. So in this first case, what we see that omega is equal to v by r. So this is the velocity and this is r. So if the r velocity is same, velocity is constant for both the cases. So if we have a bigger value in our denominator, then of course the omega will come small, and if we have a smaller value in the denominator, then the omega value will come larger. Okay, so in this case omega is equal to v by r, but if you observe for this case, what is going to happen? Omega is equal to v by 5r. So extra 5 is multiplied with r, which is going to divide with the velocity. So obviously in this case our omega is going to come less, and in this case omega is going to come more. So this is the reason why when we are standing on a platform, we observe that the train is moving with very high speed, but when we are very far from the platform or very far from the train, and when we observe it, we see that it is moving with such a less speed. Okay, so the train is moving with constant speed and our head is also rotating same angular displacement, but our head, in this case our head is rotating with more angular velocity, in this case with less angular velocity. Okay, such a easy question you see, the simple formula based question, and you will not believe that this question was asked in JEE Advance. Okay, in an MCQ type question or something like that, it was asked in JEE Advance. So this question clears an important concept for the formula v is equal to r omega. Like this we have to think, and there will be many cases which we'll find, and we need to relate it with the real world. So now a special type of article which we'll do, and we are going to wrap up today's class. So special type of article is that if two particles are moving, okay, suppose this is a block of mass and this is another block of mass. If this particle A moves with a velocity v1, which makes angle of θ1 with the horizontal, and this moves with a velocity v2, which makes another angle which is v2. So in this case what we need to do? We need to find the omega of B with respect to A. We need to find the omega of B with respect to A. Okay, so can you feel that we are going to use the concept of relative motion as we have done in our motion in a straight line, or sometimes people teach it in the projectile motion too. So the separation between them is R. What should be the omega of B with respect to A? Okay, so let us think what should be its value. As we are given the angle and a velocity is acting in a direction which is neither parallel nor perpendicular to the horizontal surface which we are given. So we can break this question into two components for both the blocks I am considering, because if we want to apply the concept of relative motion, our velocity should be in the same direction, right? Velocity should be in the same direction, or like this or like this. It may be opposite direction or it may be same direction, but it has to be in one line. Okay, so it has to be joined with a single line. It has to be joined with a single line. So our first point which we should follow, that whenever we'll see two different objects, so we will join both of them in a single line. This is our first motive which we need to follow. Second motive is that we need to break the components. We need to break the components of velocity acting in different directions, or else we'll not able to simplify. We'll be not able to simplify. See, it is acting in this direction, it is acting in this direction, so it is becoming a little complicated way. So to simplify it, we will just draw both the components. So first component is our v1 cos theta 1. The second component of the block A is v1 sin theta 1. Sin theta 1. Now, in the second case, what is happening? First component is again v2 cos theta 2. The second component is v2 cos theta 2. So, try to recall whenever we did the questions of relative motion, what we used to do. So, imagine if two particles are moving in the same direction. So, if I observe from this, what will I see? That both the velocities of if they are moving with same velocity like this in a straight line, which are parallel to each other, so what we observe that when we are sitting in this or in this, so what we observe that this train is at rest and we are moving. So while we are moving, what we observe that this block is in rest. This block is in rest. Every time we observe that this block is in rest. But if we see from this frame of reference, then we see that they both are moving with same velocity. So mathematically what we can say, that when the velocity is observed from this or this car, we subtract both the velocity or both the speed. But when they are observed in the anti-parallel direction, then the person sitting in this car will observe that this car is traveling with a higher velocity, higher speed. It is traveling with a higher speed. So in this case, we add on the velocities of these two. We add the velocity of this, we add the speed of this, and we add the speed of this. So what the person A will observe in this case is that it will observe the speed of A plus speed of B. Okay. So in a similar manner, if I sit on this object, okay, suppose I am the person, I am sitting on this object and I try to observe, what I am going to see, as we are told, we have to find the omega of B with respect to A. So there should be a person sitting on A, okay, sitting on A, there should be a person, right, sitting on A. So what that person will observe? So that person is going to observe in this direction v1 cos theta 1 and in this direction v2 sin theta 1. Okay, v1 sin theta 1. This is what the person, this is moving. Okay, but whenever we are sitting in the car, do we feel that car is moving? No, we feel that the inside the car, the people, we are rest. Okay, so what we feel is that we are not moving, we are at rest, so we are not able to see the velocities. But if we observe another car which is also moving in the same direction, like this case. Okay, if they both are moving in same direction, then, and if I am observing from this, then the velocity of this is subtracted from the velocity of the car which I am sitting on. So in this case also, I am going to subtract, or what I am going to see is this velocity v1 cos theta 1. Okay, and same goes for the above direction, that is so we are going to observe v1 sin theta 1. Okay, now again we are seeing that there are two components of velocity that I can see sitting on my car or the object. So now again, this is the object, which is having the velocity in this direction is changing its length, and this velocity component is giving the direction. It is giving the direction. Okay, it is giving the direction. Okay, can you able to understand that this is giving the direction? So when we are told to find the omega of B with respect to A, what we'll do is V2 sine theta 2 minus V1 sine theta 1 divided by R, which is the separation between two, initial separation between these two objects. Okay, so this is going to be our omega. So we are going to take this component of velocity. This component of velocity we are going to take, as this is changing the direction. Okay, so we are going to take this component. So this is a fundamental concepts. Now we'll see some question based on this. So our first question is that this is an object, this is another object, the separation between them is 2 meters. Okay, the object is moving with a velocity here 10 root 2, and the object is moving with velocity 20 root 2, or we can say it as 5 root 2. Let's consider it as 5 root 2. This angle is 45 degree and this angle is also 45 degree. Okay, with the vertical I am seeing, with the vertical. So our first point is to find out the line which is joining this both objects, both of these objects. Okay, our first thing is that. Second point, that we need to make the components of these velocities. So what we'll do, we can break this further into two components. So this is our V cos 45, that is 5, and again V sin 45, that is 5. Same goes for this case. 10 root 2 cos 45 gives 10. 10 root 2 sin 45 gives 10. Okay, I hope it is clear. The separation between both of them is 2. And now if I am sitting on A, what I observe that as we are told to find the omega of B with respect to A, so what we observe, that this particle is moving with a speed of 10 minus 5, and this is also moving with 10 minus 5. So In above direction it is moving with 5, and in this horizontal direction it is moving with 5. We know that this 5 is giving the direction. This is changing the length, and this is giving the direction. Okay, so as this is giving the direction, so omega will be this 5 divided by 2. So omega is equal to 2.5 radian per second. Okay, radian per second. If this is 2 meter, this is meter per second, this is meter per second, then this will be omega will be 2.5 radian per second. Okay, I hope you have understood this question. Now let us make a difficult question. Before moving on to further question, I want to write the points which I have told to you. Okay, the points are: first point, find the line joining two objects. This is very important line, so that I can make the components. Second is identify the velocity and make their component. Third point is we need to for relative motion, sit on particle A and write the velocity that you are going to observe write the velocity of B that you are going to observe while sitting on A. Okay, so these are the three things which we have to remember and which we have to understand. So if we try to remember, and I have also given the logic. I am not saying to memorize these three lines. Okay, I have also said why we are doing so. So if we try to remember and try to recall these all things, then we can easily solve these questions. And let me tell you that these questions are literally asked many times in JEE mains, especially in JEE mains. To sit in JEE advanced, we first need to clear the JEE mains. So we also need to master. Okay, there may be some people those who are preparing for advanced, but first we need to prepare for mains. Then we can also do like that we are preparing both simultaneously, but we must not take mains in a lighter way. Okay, because it is too important to sit for our JEE advanced examination. So these all things we have to remember in our mind. Now the second question which I want to give is, suppose this is the object and this object is moving in this direction. It makes an angle 60 degree. The velocity is equal to 10 meter per second. and there is another object here. Okay, now this object, suppose I can say this object is moving in this direction. No, this object is moving in this direction and the angle between it is 45. Okay, angle is 45, which is it is making with the horizontal angle is 45 degree. This velocity I am considering to be 2 root 2, two objects. First point is we need to find the line which is joining both of these objects. So this is that line which is joining both of this object. Okay, now we are to break the component of both. So if we take the component here, what we get? We get V cos theta, which is equal to 10 cos 60. Okay, so value will be 5 meters per second, and the perpendicular component that is V sin theta is equal to 10 root 3 by 2. So it becomes 5 root 3 meter per second. Okay, as value of sin 60 is root 3 by 2. So I can simplify it by writing like this, that this component is 5 and this component is 5 root 3. Okay, now V cos theta, which is equal to 2 root 2 into cos 45. So the value of V cos theta is equal to 2 and V sin theta will also equal to 2. So overall thing becomes like this. Okay, overall thing becomes like this. Now if we sit on A and we sit on B, we can easily observe it. Okay, we can easily observe. So if I sit on A, what I will observe, that this object is moving with a velocity of 2 minus 5. Now can you see the velocity is equal to minus 3 meter per second in this direction, and also in the above direction what we see 2 minus 5 root 3 meter per second. Okay, so can you see that negative sign has arisen before the velocity. Now what does this negative sign means? So you must have studied in the kinematics, that this means that the object is moving away, and from here I can see that it was in rest, right? When it was moving with same velocity, they both were at rest, but now this car starts speeding, and this automatically, when we look from here, this is moving with some velocity, and what we see is that it is moving backwards in the backward direction. So the velocity has the negative sign here. Okay, same goes for up, but we are not to focus with that, we are just to find omega. Okay, so if this is r, then our omega will be of 2 minus 5 root 3 divided by r radian per second. Okay, now in jeemains they may ask that why this negative sign arises, or they may also make a case based question on this. They can make, yes, they can easily make. Now I hope this article is clear to you. Okay, so as this is going to be our last lecture, let us quickly now summarize the circular motion, uniform circular motion and non-uniform circular motion. Okay, some formulas also they are left which I have not told you, and I was waiting for this class that after finishing these all concepts I will tell you. So we'll have a overall revision of our whole chapter. Okay, we understood the first basic concept, then we understood how to find this. Okay, we also did many good questions in our second lecture. You can also see that we also done the derivation of banking of rod. Okay, banking of road, we also done the derivation. We also find the maximum and minimum velocity. So if we will revise the circular motion, that uniform circular motion, what are the points which I wrote in the first lecture and second lecture, what were the points, and non-uniform motion if I write, then this lecture will be some concept clearing, some basics concept clearing, and revision of all 3 lectures and a summary lecture of whole circular motion. Okay, so let's start. Now first, uniform circular motion. So in a uniform circular motion, what happens that suppose object is moving in a circular track and it is having a velocity v in this direction, but the magnitude of velocity is constant. So in this case what we say, that the particle is doing uniform circular motion. Let consider the radius of the circle r. Okay, so in this case what we say, that the particle is doing a uniform circular motion. So a particle is there are 2 types of acceleration which is acting upon it. That is, one acceleration is tangential acceleration, another acceleration is the centripetal acceleration, which is the reason for the centripetal force. Okay, so here, as the velocity or the magnitude of velocity is constant, here magnitude of velocity is constant, therefore there is no change in the magnitude of velocity with respect to time. Therefore we will say that tangential acceleration in this case is 0. Okay, tangential acceleration in this case becomes 0. Now what we can say, but can the centripetal acceleration value will be 0? No, centripetal acceleration value is not equal to 0. Okay, is the centripetal acceleration value is not equal to 0. So how can we find the value of centripetal acceleration? So the value of centripetal acceleration is v square by r. This is the value of centripetal acceleration. Okay, at this point the velocity of the circular motion is in this direction. When the particle comes here, then the direction will be this. When it goes there, then the velocity direction will be here. When it comes here, then its velocity will be in this direction. So can you see that the direction of velocity is changing? We know that velocity is a vector quantity. So whenever there is a vector quantity, there are 2 things. First is its magnitude, and the second thing is its direction, that I am representing it v cap, which is an unit vector. Okay, or I am writing it direction. So the magnitude of velocity is same, it is constant, it is same, but the direction is changing. So the velocity will change. Velocity is going to change. At every time, at different time, there are going to be different velocities. So if there is a change in velocity, therefore we can say that it may be uniform circular motion. The velocity is constant. Magnitude of velocity is constant, but direction of velocity is not constant. Therefore, this is a accelerated motion. Okay, this is accelerated motion. Okay, can you able to understand? This is the thing. So this is accelerated motion. Now, if we want to calculate the omega, what used to be the omega? Omega is equal to V by R. We saw the derivation today, right? There are two derivations. The second derivation we saw in the beginning of this lecture. So V is equal to R omega. This is one formula. Okay, V is equal to R omega, where V is the speed, R is the radius of the circle, and omega is the angular velocity. Okay, omega is the angular velocity. If we differentiate this both side, then what we get is that the tangential acceleration value is equal to R times alpha. In this case, the value of tangential acceleration is equal to 0. So R alpha becomes 0, and R is having a constant, R is having a value. Okay, R is having a value, and we know that whenever a product of two things becomes 0, then either of any one has to be 0 or both has to be 0. So here both can't be 0 because R has a certain value. So we can say that the angular acceleration in this case is 0. The angular acceleration is 0. Okay, the angular acceleration is 0. So now let us revise little bit previous concept, that this is theta. Okay, d theta by d theta by time gives omega. Okay, d omega by dt gives us angular acceleration. Okay, we can also write it as the second order derivative of angular displacement. Right, like this we can write. Now one more important formula is that if we want to find the velocity or the speed, okay, speed which is constant. So if we want to find that speed, what we can do? So we memorize the formula that speed is distance by time. So in this case, for the whole path, what is the distance? The distance is the circumference of the circle. Okay, that is 2 pi r, and if that circumference is covered in time t, then the velocity is equal to 2 pi r divided by t. Velocity is equal to 2 pi r divided by t. Okay, I am erasing this part and I am writing the formulas. Okay, I hope this part has been understood by you. So I am writing only the formulas because space is less. So the first formula is that V is equal to R omega, tangential acceleration is equal to R alpha. In this case, alpha is equal to 0. Okay, since tangential acceleration is equal to 0, V is a magnitude of V is constant. In this case, this is accelerated motion. How accelerated motion, that reason I have explained already. Okay, this is accelerated motion. Now I have also derived one more formula, that is velocity is equal to 2 pi r by t. Okay, I hope it is clear. Now from this we can also find out that time is equal to 2 pi r by v. Okay, now what is the value of v? V is equal to r times omega. So time is equal to 2 pi r by r omega. R gets cancelled. So omega is equal to, so what is the value of omega? If you want to find in this term, omega is equal to 2 pi by t, because r gets cancelled. So omega becomes 2 pi by t. Okay. Now we have not read the waves chapter. Okay, it is in the last part of our physics. It is an independent chapter, we can read it anytime, but first let us focus on mechanics. But in class 9 we have already learned sound chapter, where we learned what is frequency. So frequency is equal to 1 by time period. Okay, 1 by time period. So this formula can be again modified into omega is equal to 2 pi into frequency, that is f. Velocity can be also modified into 2 pi r into f, which is equal to our velocity. We can write in terms of frequency, though very less questions are asked in this manner, but we can write. Okay, so here omega, let me show the derivation again. 2 pi r omega is equal to t. R gets cancelled, omega goes there, 2 pi by t gives us omega. So these are all the things which we have already studied and we have recalled in one single paper. Okay, we have recalled everything which we have studied till now. Now for non-uniform motion, so now non-uniform motion. So non-uniform motion is very easy. Okay, if you have understood this part, then there is no problem to understand this. So this is tangential acceleration, which is acting. So here the tangential acceleration is not equal to 0, and neither the centripetal acceleration is equal to 0. So both of them are not equal to 0. Tangential acceleration is changing the magnitude of speed, whether it is decreasing, increasing. Okay, and centripetal acceleration is changing the direction. So this is the first thing. Now here, as we have learned today, so we have learned that how this position vector, and this was final position vector, this was the velocity in this direction. So it had a component here, that is v sin theta and v cos theta. This v sin theta we wrote, this was v cos theta, and here a component was acting v sin theta. So this v cos theta was equal to differentiation of the magnitude of the initial position vector with respect to time. So similarly, in this case also we see that the tangential acceleration is changing the magnitude of velocity. So we can write that the tangential acceleration value is equal to dv by dt. Okay, we know. So we have also understood that why tangential acceleration is differentiation of speed with respect to time, and the centripetal acceleration is differentiation of velocity with respect to time. Okay, as you can see, I have applied the vector sign, so it is velocity. We can write it like this, and rest all the formulas remain same. That is v is equal to r omega, omega is equal to 2 pi by t, velocity is equal to 2 pi r by t. Okay, time is equal to 2 pi r by velocity. Rest all formula remains same. If we differentiate, then what we get? tangential acceleration is equal to r alpha, right? In this case, as tangential acceleration is not equal to 0, so there must be an angular acceleration which is also not equal to 0, and omega is obviously not equal to 0. Okay, we can also write these formulas in terms of frequency. Okay, so I hope you have enjoyed my video, and today we have finished our chapter. Okay, we have finished the circular motion part. We have finished our chapter. It was very important and it cleared our basic concepts very much, and this concept will be used in our further classes, like work power energy. We are going to find out the velocity of circular motion at different areas. Okay, different points we are going to find out the velocity, and then again center of mass will use all this omega, okay, angular displacement, angular velocity, angular acceleration. Will use this all physical quantities which this chapter taught us, and in rotation chapter there will be several more physical quantities which will be introduced, like torque, angular momentum, moment of inertia. New concepts we'll learn. So by the end of this video we have finished the circular motion chapter with completion of 4th lecture. So please keep supporting me. That's all from my side. Thank you. Jai Hind, Jai Bharat.